So yeah, I'm Lee Adcock. I'm the Sustainability Director for Genuit. What I'm going to talk to you today about is how we use EPDs in our business planning processes. So how that fits into our whole journey around sustainability. So that's the aim of the day. So if I don't do that, you can come and find me later and tell me. So in terms of who we are, just very quickly, Genuit is a group of companies, FTSE 250 listed, about 3,500 employees, 25 production sites, pretty much all in the UK, and a market-leading position on a lot of materials we sell into. And we'll talk about it a little bit more in a moment, but our guiding purpose is the statement, together we create sustainable living. So that's the thing to remember as we kind of move through some of these other slides. Again, just a little bit more about us. We're split into 3 different business units. Each of them primarily are centered around either climate adaptation or climate mitigation in terms of the solutions we're selling. And you can see some of the brands underneath. We talked about some of them a little bit earlier. We own people like Polypipe, Keytech, Manthorpe, AD, New Air, and lots of others. And all of those are offering different, what we would say, are climate mitigation or adaptation solutions in the built environment. So the question is, how do EPDs fit into our story? Because obviously, maybe obviously, given where we are, we produce EPDs because people want them, probably some of you in the room. But they also fit into our journey in a different way as well. And when we think about just some basics about the business, we're a listed company. We've got a very strong board that has really embedded sustainability in the heart of the business. So we mentioned before, we have this statement, together we create sustainable living. That's our purpose statement, and that's what we do. But more specifically than that, on sustainability, we actually say that we want to be the lowest carbon supplier of choice. So that means that's what we want to do in terms of being sustainable. We want to be the lowest carbon supplier of choice. And our sustainability framework, you can see on the right-hand side there, has got climate change at the top, as well as people, solutions, and advancing the circular economy as well. So all the way through, we can see sustainability and carbon has been key to the way we want to run the business. That's the purpose statement. If you go off and look at things like the annual report and different bits and pieces, that's how we show that to the outside world. And what I would just say is, again, think about what I just said before, we have that we want to be the lowest carbon supplier of choice as one of the core 4 pillars of our business. So it's not just something we do or say or add in, it's actually right at the core alongside growth, business systems and people and culture as well. So that's just where we are. So when we kind of reflect on that and what that means, I think quite clearly when you go off and have a look at the data, we've been doing good. You can see top left-hand corner, over the last 10 years or so, we've been decreasing our carbon intensity and our absolute carbon emissions. So up from, I guess, a peak of just over 60,000 tonnes, scope 1, scope 2, down to about 15,000 tonnes. And then scope 3, where the bulk of our emissions are, you can't see the numbers, are a little bit small, but peak maybe about 425,000 down to about just under 300,000. So you can see some fairly big reductions. But what does that mean for a product level? Because that's global level, isn't it? So we've got lots of businesses, 26 different sites, lots of things going on. How does that translate to an individual product that somebody might buy or somebody might specify? And when we think back to that purpose we've set ourselves and that challenge, how do we demonstrate that we're the lowest carbon supplier of choice? And I would say, what we see is we need product level action. So not just global emissions, but how do we affect the embedded carbon of the individual products themselves? Unfortunately, we've got some tools, unsurprisingly. That's why we're all here, right? So life cycle analysis to the rescue. That's how we provide the evidence and the information to customers and to clients and to other people that want to know what we're doing. So that's kind of a tick box piece, right, isn't it? So that's if somebody wants some information, we produce an EPD, we put it out there, ends up on a database, you can find it, happy days. But it's not just a tick box exercise. they also provide some really important information that help us find opportunities for improvement. And that's what I'm going to try and show you and talk you through some examples of where we've done that. So not just where we're producing EPDs for the sake of producing them, but where we're producing them and then using them back in our own business planning and how we're actually making improvements in our operations. And you're familiar with this. We've seen this a couple of times today. You know, this is obviously the EPD LCA sections. A1 to A3 is what we typically talked about earlier, but you've got these other ones as well. So just useful to remember that. Pretty sure everyone in the room probably knows that better than I do. But when we come back and look at some of the data in a minute, interesting to think about that and where we're actually trying to pull the right levers on those different products. So what I'm going to do is just talk you through on a couple of slides, just a couple of different materials and how that different LCA values look. First one, very glamorous product there, but it's a radiator pipe guide. So we sell these go into lots of different places, and where you've got maybe plastic pipes for radiators, they sit behind them and you can guide the pipes through them. So very straightforward. And what you can see from those, and hopefully you can see that from the diagram on the top left-hand side there, is that when you look at the A1 to A3 and the other values, that actually, for that material, one of the largest contributors to its embedded carbon is actually raw materials. And unsurprisingly, you can actually see when you look at that, that's actually using virgin raw materials. So it's using virgin polymer, no recycled content at the moment. But it's electro-intensive because it takes a lot of energy to mould those in a big plastic moulding machine. But that moulding machine is using 100% renewable electricity. So unsurprisingly, when you look at the A3 value, it's a bit smaller than it might do, because if it was using standard grid emission factors, that would be a little bit bigger. So the focus for that product for us is how we can move away from virgin raw materials. So that site's looking at that and trying to use more recycled material on that, which would have a fairly big contributor to that, because the A1 value, I don't even know what that is, but maybe 55, well no, 60%, 65% maybe over total emissions. So if we look at another one, this one's quite interesting. I was talking to somebody earlier, kind of alluding to this one. So this is Polyplum brand, or the trade name for one of our polypipe products, and it's what we call a barrier or a flexible polybutylene pipe. So anyone that's got underfloor heating, that's the stuff you've got in your underfloor heating pipes. Very good at withstanding lots of different temperatures. Interestingly, this time, if you think about the one on the left-hand side, you see also on this one quite a lot of emissions associated with the raw materials, but this time it's about a third, I would say, more or less, looking at that, maybe a little bit less. And interestingly, A2 all of a sudden becomes the other dominant thing that we can see. And when we look at that and look at how we make that, that's currently made with virgin raw material again, but it's actually transported a fairly significant distance in terms of that raw material to where we manufacture. So because of that, the A2 value is pretty high, as well as the A1. So this one, locally sourced virgin raw material. This one, virgin material but sourced from further away. And you can see that difference. So there we focus in on whether we can move that material to a more locally sourced raw material, which is useful given the global compass, a manufacturer's compass, material compass. We saw earlier whether we can find that. Both of these, or actually this one on the right, is a bit of an issue for us as well, because it uses a virgin raw material, but it's actually manufactured to a British standard. The British standard specifies virgin material. So our ability to do something on this side with the material is a bit limited. That one, I don't believe, is a British standard limiting factor, so potentially we can do a bit more in terms of switching. So there you can see how we're trying to use the data to help guide us into making the right decisions. Just a couple more. This is a product called Rigid Drain. So this is big land drain. Drive past any national highways projects up and down the motorways, you'll see this stuff being laid to manage the surface water drain off and run off from those big motorways. You can see this time, interestingly, it's recycled material, so 100% recycled material. But still, it forms one of the largest parts of the pie of the whole life carbon. So that's a bit of a challenge because it's already decarbonised raw material. Actually, interestingly, the site that does that also runs on 100% renewable electricity. So really, there's not much we can do on the raw material. There's not much we can do on the manufacture. But what you can see is the installation, when you go to install it, is quite significant. In fact, the installation emissions, about 11%, are larger than all of our manufacturing emissions. So even though we've done everything we can, there's still a fairly significant amount around installation. So what we need to do is look at how we can help people install it and lower that embedded carbon associated with the installation. So this is it's a different one, different than the other materials where it's all in our domain. Now it's about how we can influence that installation and not just how we make the material. And then just as a comparison, so you notice the one on the left, it's rigid drain, 450 to 650 millimetres. The one on the right is actually bigger, up to just short of a metre. And when you compare them, it's interesting. I think we were talking earlier about how you make things and how that affects embedded carbon. You can see with those larger diameter, it's actually the manufacturing emissions go up fairly significantly. So you need a lot more energy to make bigger pipes. So I'm sure hopefully none of our salespeople are in here because I get shot later. But from a life cycle perspective, you might consider, if you can use a 660 diameter pipe rather than a 750, you probably get a fairly decent reduction in embedded carbon if you just make that small change, if that's possible. And again, installation emissions are fairly significant. So, whatever we can do to help installers minimise that, then there's probably some genuine savings there. And then the last couple to look at, so these are HDPE, so high-density polyethylene soil pipes and waste pipes, so kind of things you see on the back of bathrooms, toilets and whatnot, so they're taking sewage and dirty water away. And again, these are made with 100% a large portion recycled materials, and you can see again that one of the largest portions of carbon is coming from that raw material supply. But this time, interestingly, I would say that the transport emissions and then the manufacturing are about the same. So clearly we're moving material around quite a little bit more than some of the other sites, and we've got a bit more manufacturing emissions there. And this is interesting from my perspective because the products we saw on the last slide, these, especially this one where the A3 value is very small, is made at a different manufacturing site than this. So this tells me there's something different going on between those two sites, something different in terms of the power configuration or whatever they're doing, which is absolutely the case. There's some structural reasons why there's more carbon associated with the manufacture of the terrain than there is the rigid drain. And again, just going to a different material, so we also do something similar in that same range, this time with PVC. So that one's HDPE, this one's PVC, and you start to see that the raw material takes a bigger portion. So again, if you're choosing one between the other, then there might be some differences there. And for the first time out of all of these six, waste disposal is more significant. So there's some end-of-life issues associated with that. It's a solvent-welded pipe, it's PVC, which tends to be more difficult to recycle than HDPE. So there's some greater emissions associated with that we need to think about. So from our perspective, how can we design for reuse? How can we design for recycling? Or how can we help that end-of-life position? So that's kind of like, that gives us all the things that we need to think about. So there's lots of ways we could use that LCA EPD data to get us to think about what we're doing from a manufacturing perspective. I'm just going to run you through just some of the things. So this is from a our sustainability report from this year about what we're actually doing to improve this. So you can see we're using more recycled PVC, trying to bring some of our end-of-life material back and reusing it directly. Rainwater harvesting, biofuels, electric vehicles, other recycled materials, and using alternative materials and lightweighting as well. So there's lots of things on all of those are directly picked to try and address some of the elements of the EPD values we talked about before. So where we talked about raw material choice, using different materials, what we can do on site, all those things are designed to try and reduce that embedded carbon and get us lower embedded carbon values. Because that's what we're after. And that's the target we set ourselves. So if you remember back from the start, we said we wanted to be the lowest carbon supplier of choice. And the only way we can do that is by using EPDs that show that we're the lowest carbon supplier of choice. So I think the $65,000 question, or the proof in the pudding, is how well we're doing. Are we actually making things that are lower embedded carbon than our competitor or potential competitor materials? And the answer is yes. And this is just a couple of examples that we've seen before. And when you look across, look at our terrain underground pipe. This is kind of pipe that you would have running services away from houses or small commercial buildings. Around about 1 kilogram of CO2 per metre, I believe that is. About 1.5 for generic virgin alternative, or about 7.5 for cast iron pipe. So that's how that translates through. So we take action, we look at the EPD values, take action, and actually get that low embedded carbon value. And again, when you look at our bigger land drain, so this is the rigid drain that we looked at before, that's 300. The others were like 450, but basically the same product. 100% recycled HDPE, made with 100% renewable electricity. EPD value is about 3.6. Typically, we're competing against concrete pipe. That's like 27 for an alternative, for a comparable length of pipe. So you can see then how that's having a positive impact. And that's what we do as a business. That's what we're trying to do. We want to be the lowest carbon supplier of choice. And we're using EPDs to try and identify the areas to work on to keep those values coming down and live to our mission statement. And that's it. Thank you for listening.
Thanks, Lee. Questions? I'm going to start with one because I have one. Those numbers are impressive and the comparisons are impressive. What impact have you seen in terms of specification? Like, has it actually had an impact on you commercially?
Yeah, and that's probably one of the hottest topics within the business from a sustainability perspective. It's mixed. It's mixed, and it shouldn't be. We talked about UK GBC. There's a future home standard. There's lots of things that suggest we should be using low carbon materials. I think we're in an interesting point where my perspective is that if you're talking to someone who's designing a commercial building, they're focusing on the big materials, right? So they're focusing on concrete and steel and the heavyweight carbon materials. I think there's a danger, if we're not careful, that we lose focus on the rest of the materials, and that we need to not do that because some people know my background, ex-steel, so I know that world very well. That will only decarbonise so far, and it's not to net zero. So you will not buy net zero steel in the next couple of decades because it's physically impossible. You need carbon, you need things to drive that process. So you've got to look at decarbonising the rest of the materials. And if we don't, we're going to hit a plateau and not go any further. So I think that's the hot topic: is how do we get that message across? And I think the materials compass is maybe one of the answers, along with lots of other things. But we need to keep driving and not just stop at the easy materials.
The Global Manufacturing Materials Compass.
Yeah.
Great, thank you. Any more?
Hi there, my name is Kira Kenny from Lundleys. Now, most companies that have a science-based target will have interim targets for their organization. Given the granular information that you're getting from your EPDs, are you setting targets per product over time as well as doing an organization-wide one?
No, in simple terms. But it is an interesting point. So we've got science-based targets. We've got a 30% reduction target, scope 1 and 2. We've got an engagement target for scope 3. I think, and part of the presentation is genuine actually, and I think genuinely the board helped by setting that mantra they want to be the lowest carbon supplier of choice, because there is the danger that there's a disconnect between a product and your global emissions. So we're a large manufacturer, we've got lots of sites. We could achieve the targets, if I'm honest, in a handful of sites and ignore the rest. And we wouldn't have decarbonised products. We would have a decarbonised business, but not necessarily products that people need. So there is a disconnect between SBTs and what we're doing at a corporate level and product. And we're trying to tighten that a little bit, but it's not there. But it's an obvious next iteration, I think.
First of all, thanks a lot for the great presentation. A quick question about, let's say, the last example that you gave, waste disposal was found to be one of the second largest impact creator around this, and you're then consciously trying to minimize that, right, subsequently. How do you balance that with cost, really, right? I mean, eventually that's what the question boils down to. Yeah. Do you use any tooling for that, like standard, to be able to do so, or how long does it actually take to get to a decision that, okay, we will now use something completely different so that it's more sustainable?
Yeah. So if I kind of answer that kind of like in reverse order, because of the way we operate, we can actually make decisions fairly quickly. So we're kind of a large group of disaggregated businesses to some extent. So the good news is we can tend to move fairly quickly. I think the difficult thing is, you're absolutely right, and this is what I was alluding to with the EPDs earlier. There's still large segments of the housing market that is entirely only operating on cost. They're not they say they are, but at the end of the day, they're not really factoring in EPDs, embedded carbon, on a parity with price. So at the end of the day, you know, there's always that tension between, yes, we could do something, price could go up, but then do we get despecified, and then we're not selling product. So there's a balance to work on there that's not necessarily in the right place, I would say, at the minute. But that's where we're trying to find. And so you know, if you fancy those examples, you know, you think about that. We've got sites that are running on 100% renewable power. There's a cost of that. We've got sites that use 100% recycled material. There's a cost of that. You know, we're trying to build that through, but there is always that tension between what someone's willing to pay and how far we can push for decarbonisation.
Thank you. The figures you had up were all, factoring in the upfront carbon. Do you also look at the end-of-life circularity and impacts there as well?
Yeah, we do. Yeah, we do. And you know, it's to some extent it's difficult, right? Because we make plastic things. You know, so that's a challenge for us. So we do have a lot of consideration for how we design for reuse or for recycling. And we use a lot of recycled content ourselves, so we use about 50% of the recycled content. Our sustainability manager, I think his favourite quote from a year or so ago was, I think we use more recycled plastic than Wales collects annually. So that's just a number for you for what Polypipe's doing in terms of using recycled materials. But yeah, it's always you know, that you have to think about that as well. You can't, and I would say, you know, I think there is an issue broadly that we have waxed and waned. If you go back 2 or 3 years, focus on for the plastic sector, polymer sector was on circularity. That was kind of the main hot topic that everyone wants to talk about. Now it's carbon. And it is difficult in the longer term planning cycle when we do slip in and out, you know, of these different hot topics. What we're trying to do going forward is bring them together. So how can we bring circularity thinking and decarbonisation together in a way where they're not conflicting? Because there are examples where they do conflict. And if anyone's interested, I can talk later. But using recycled materials, despite what that says, doesn't always have the obvious decarbonisation output you'd expect. So there is some conflict with some materials.